may know about the probability theory, but we will just to review the basics of probability theory, because we will study this course based on the probability theory and apply some algorithms which rely on probability theorems. So this is the content of this lecture, and we will study events. What is the probability event, how to calculate the probability event, and the axioms of probability, probability probability density function and random variables, then mixed random variable, mixed probability PDF, expectation moments of scalar random variable, joint PDF of two random variable, independent events and independent random variables, conditional probability and PDF, total probability theorem, Bayes formula. There are other few content of this chapter that we will cover in the next class. So, what is a random phenomenon? There are two phenomena. Means in probability theory, we can divide two parts of random variable. Random phenomena may be deterministic or non-deterministic. In deterministic, we have model of the object. In non-deterministic, we don't know about the model. It is undetermined. In non-deterministic is not determined. So deterministic, there exists a mathematical model, means you know already the model of the object, that allows perfect prediction the phenomena's outcome. Many examples exist in physics, chemistry, like motion model. You already know motion model. Okay, so we have motion model. We add velocity to the position to calculate the next position. We have already a formula. We have already known the model. Non-deterministic phenomena, it has no mathematical model, but it allows perfect prediction the phenomenon outcome. We can also drive, or we can also make a model of the object. If it is undetermined, then we can also drive the model. So in both cases, both cases allow perfect prediction the phenomena's outcome. Non-deterministic may be divided into two groups: random phenomena and haphazard phenomena. Random, what is random phenomena? It is unable to predict the outcome, but in the long run, the outcomes exhibit statistical regularity. Means, for example, rolling a die experiment, it is a random phenomenon, unable to predict, because we roll a die, we don't know what is the outcome, so unable to predict. But in the long term, the outcome exhibit statistical regularity. And the next phenomena is unpredictable outcome, but no long run exhibition of statistical regularity in the outcomes. Means in this case we cannot find outcome, and in the long run also we cannot find the outcome, because it has infinite points active, and all infinite points are non-deterministic. So in this case we cannot predict any outcomes. So in this case we can divide the phenomena. So So already we know deterministic. Deterministic job is very easy, and non-deterministic job is very difficult. So we have to study the random phenomena in the subject, because object may be non-deterministic but have a random phenomena unable to predict, but in the long run the outcome exhibit statistical regularity. For example, tossing a coin. So there are two outcomes, head or tail, unable to predict on each toss whether it is head or tail, but in the long run can predict that 50% of the time head will occur and 50% of the time tails will occur. And this is the same example, rolling the die, unable to predict outcome, but in the long run one can determine that each outcome will occur 1/6 of the time. Okay, so the probability of each outcome is 1/6. So using symmetry, each side is the same. One side should not occur more frequently than another side in the long run. So in the long run, suppose the two dots will occur, but two dots, if we roll 10 times, then it is rare that two will occur most of the time. Two will occur most of the time. It is very rare. So if the die is not balanced, this may be not true. Okay, for example, what is sample space? Suppose this classroom is a sample space. There are many random variable, and you four people are the event, means a partition out of this sample space. So sample space for a random phenomena is a set of all possible outcomes. So every object has a possible outcome, and you are the event, a partition from all over the outcomes. So example, in the tossing a coin, the S sample space, only two outcomes, head and tail, and rolling die has 6 outcomes, 1, 2, 3, 4, 5, 6. An event, what is event? Is any subset of the sample space S. Like you four students are the event of this sample space classroom. So there is any set of outcomes of random phenomena. This is whole sample space, but this is only the event, means a part of one part of whole sample space. So the event is said to have occurred if after the outcome has been observed, the outcome lies in A. Means if it occurred and detected, it can be observed and the outcome lies in A. Okay. So for example, the sample space is given by 1, 2, 3, 4, 5, 6, but the event, that the event number is rolled. Okay, you have been asked that in the rolling die experiment, you know the sample space, but I'm asking you the event. You have to find the probability of the event, that when you roll a die, it always occur a even number. It always occur a even number, either 2 or 4 or 6. But always, what is probability? You have. I'm asking what is the probability of the event that it occur in the sample space. So this is the only part of the whole sample space. And the null event, the empty event phi, the event that contains no outcomes, the entire event, the sample space S. Okay, the event that contains all outcomes, and the empty event never occurs. So union set of operation, let A and B two events, then union of A and B is the event denoted by A union set B defined by this one, and it will equals, suppose this is assumed set that E any random variable belongs to A or belongs to B, and this union we just add all number, whatever elements lie in A and whatever elements lie in B, we just add. Still we do not know E belongs to A or belongs to B, but in this case we add all the elements together. The event A U B occurs if the event A occurs or event B occurs, and in the intersection, let A and B two events, then intersection of A and B is the event denoted by A and B defined by A and B equals to, here E any random variable belongs to E and E belongs to B, means they are common intersection, means E lies in A as well as in B, common. So the event A intersection B occurs if the event A occurs and the event B occurs. Both random variable occurs in both sides. And the complement is opposite of some random variable, means put the complement over A, that E does not belongs to A. So suppose in this sample space this other part is not belongs to A, this part and this whole part is separate, and both do not belong to each other. So the event A bar occurs if the event A does not occur. Now mutually exclusive means two events A and B called mutually exclusive if A intersection B is equals to phi set, because two events cannot occur at the same time. Okay, mutually exclusive means that two events cannot occur at the same time. Only one of the event may be true and other should be false. So therefore that is the reason that A intersection B equals to 5, because 0, because this 5 set is not 0. This means empty set. This is not 0 but empty set. Empty and 0 set is different. Both are different things in the statistics theory. So this is null set and cannot occur at the same time. So they have no outcome in common. They can't occur at the same time. The outcome of the random experiment cannot belong to both A and B. Okay, then the probability of the events. The probability of an event E, suppose that sample space is 0, 1, O, O1, O2, O3 and up to On has a finite number n. So outcomes, this is outcome. Also each of the outcome is equally likely because of symmetry. Because likely means any event can occur. Okay, and then for any event E, the probability of event is number of outcomes E and total number of outcomes. For example, 10 numbers, and the number of outcomes in E. What is E? What you have been asked for. Suppose you have been asked for to find the even number, then count the number of even number. So 4 number, 2, 6, 8, 10, 4 numbers in the set of 1 to 10, 4 number. So this is a 4 number of outcomes in E divided by total number of outcomes 10. 4 divided by 10. So probability of the event that only even number can occur in the total sample space is 4 divided by 10. So thus by definition it applies only to the special case when the sample space has a finite number of outcomes and each outcome is equiprobable. Means each outcome or each random variable has a probability that it will occur. It will definitely occur because it has a non-negative value, and it has and it is finite number. So if this is not true, a more general definition of probability is required, because if it is wrong, then a more general information of the probability is required. Axioms of probability or the rules of probability. So there are 3 rules. One is non-negative, means the probability of any event A is greater than. When I talk about event, then it is suppose a part, one part of whole sample space. Okay, and sample space is plenty of random variables, means plenty of outcomes, and event have few outcomes that one can ask you to find the probability of event. So the probability of the event has 3 axioms. One is it is non-negative, greater than or equal to 0. It is unity for the sure event. Sure event is that when it occurs, it's only unity. Means the event do not has 2 value. Okay, or you can say that the event it is not multiples of the events, it is only unity. Okay, so unity means P of S 1, and it is additive over the union of mutually exclusive events. For example, if the event A and B have no common elements, their intersection is the empty set. So it is additive over the union set, means A intersection B equals to A comma B is empty set. In other words, their union or logical OR has probability like this: A union B or A plus B equals to A of P of A or P of B, means total probability of the 2 sets is equal to the sum of the individual probability of the set. And from above it follows that the probability of A is equals to 1 minus probability of A bar. What is A bar? A bar is it is that A is not part of this, or A does not belong to this. What is probability? That A does not exist, does not lie. So for rolling die experiment, the space outcome is S equals to F1, 2, 3, 6, where Fi denotes the phase I, and the sure event S equals to any phase, means sure event any phase can occur. Okay, then what is the probabilities? Probabilities are assigned, postulated, means postulated means assume, for each element of S, each outcome. So each outcome has a probability. So each probability are calculated and assigned. So postulating of fear type has axioms 2 and 3. Means it has property of additive property, and it has property of the sure event. That any event can occur, but it has unity property. For example, this rolling die experiment, that sure event P of S is always equals to 1, because sum of P Fi is equals to 6 Pf, because there are 6 events. One has also unity. One can occur one time, and 2 can occur 2 times. So 1, 2, 3, 6. There are 6. You can say magnitude. There are 6 magnitude. Then 6 P of Fi, where I equals to 1, 2, 3, 6. So it will equal to 1 over 6. So it follows that with axioms 3, that probability of the I, what is the even number? We want to calculate the probability of A. So suppose you have been asked to find the probability of the even number, then F2, F4, F6. Okay, then it will equals to 1 over 2, because 1, 2, 3. 3 divided by 6 is 1 over 2. Okay, rules, additivity rules. Okay, this is already discussed. That is A, U, B, because individual probability of A and B. So, like, okay, in general, A, U, B equals to A, probability of A and probability B minus probability of A intersection B, because when we combine, when we make two events together, there is at least one value common in both set, and when we merge two set together, there are some value that is common in both things. So we have to minus this thing. We have to minus this thing, and then B of probability of A or B equals to this thing. Suppose this two set, and this is also common. Then when A is added to B, the outcome is in A intersection B are counted twice. This part is counted twice, hence we subtract this part. Okay, to calculate the probability of A and B. So probability of A union B equals to probability of A plus probability of B minus. Why we subtract? Because otherwise it will count it twice time, because that number, suppose 2 is occur in A and B, so it will count it 2 times. Okay, so for example, this is example that Saskatoon and Mactan are two of the cities competing for the World University Games. There are also many other. The organizer of narrowing the competition to the 5 cities. Only 5 cities will be selected for the final. There is a 20% chance that Saskatoon will be amongst the final 5. There is 35% chance that Mactan will be amongst the final 5, and 8% chance that both cities will be amongst the final 5. Then what is the probability that both cities will be amongst the final 5? So suppose let A, there are 2 events, the Saskatoon amongst the final 5 times, final 5, and let B is the event that Mactan is amongst the final 5. Then what is the probability of this one? It's 20% for this city and 35% for this city. So 20% means probability of A equals to 0.2 and B equals to 0.35, and what is probability of that both will selected for the final 5 is only 8%, so that's why it is equals to 0.08. Now what is the union of B? Then put the values and equals to 0.47. So only 0.47 is the probability that both cities will be selected for the final 5 in the competition. Then rules for the complement that probability of A or not A equals to 1 minus P of A. So in the when we develop the algorithms, this is important that we find the object existence in the tracking of the object tracking, because in the object tracking, object can exist and cannot exist. Means suppose this is a target A, so either target A can occur and either target A cannot occur. There is only one event in this whole simplest case. We are finding only one target, so there is only one event. In the multiple events, maybe the multiple target scenario, but if only one event, then for example we are finding and tracking only one target, then event A. So what is the probability that it occur? The probability of the A is occur is P of A, that discussed in the previous slide, and what is the probability that it cannot occur? It is minus 1 minus P of A. So for example, the probability of A is high, suppose 0.8, then 1 minus 0.8, that is 0.2. So probability of A dash means the probability that the object cannot exist is only 0.2. So, and also the object exist and not exist, both cannot occur together, both are mutually exclusive. Only one of the event can occur, one of the event can happen. Object exist, P of A exist, or it cannot exist. So both elements are mutually exclusive, means they don't have common value, or they cannot occur at the same time. So suppose S equals to A union B, then P of S equals to 1 equals to P of A plus P of B, and P of A equals to 1 minus P of A. That's why the P of A dash equals to 1 minus P of A. Then random variable and the probability density function. Now random variable may be any scalar variable and the real valued function that assumes a certain value according to the outcome of the random experiment. Means in the rolling the experiment, then random variable cannot be 7. Random variable cannot be 8 because there is no 8 or 7 in the sample space. So random variable can be any number, but it must lie in the sample space. So that assume a certain value according to the outcome of the random experiment, that the random variable may be 1, 2, 3, 4, 5, 6 in the rolling die experiment. So the PDF probability density function of a scalar value random variable x at x equals to any random variable. Suppose x is a random variable, but at this point, suppose x equals to 2, then PDF of 2 where x is any random variables, mean 1, 2, 3, 4, 5, 6. So P of 2 is equals to the x probability of x, and this x lies between this random variable, and this is the difference of the random variable and this random variable, divided by difference of the epsilon, where epsilon is included in the x. So this must be greater than or equal to 0. So the probability where P dot means this term is the probability of the event 1. So the more common notation is P of x. So more common notation for PDF is P of x or P of x, this way. From equation 6 and axiom number 3, that is additivity rule, it follows that P of random variable lies eta to any value. What do we say, this epsilon or variant? Anyway, I call it epsilon, but epsilon is another symbol. So eta and epsilon. So integral of eta and epsilon is the integral of this random PDF of the random variable. So we also call this thing as a distribution. So above function is called cumulative probability distribution function of x at epsilon, and this is usually referred as distribution. And from this equation, assume that this is a sure event. X is less than or equals to infinity. Assume that the sure event is this one. Then sure event probability is sum of integral of minus infinity to infinity equal to this function equals to 1, because we have to normalize P of x, and the normalization property allows that its total probability mass equals to unity. So what does it mean? The total distribution or total PDF of random variable must be equals to 1. Now the Gaussian normal random variable with mean and variance symbolically denoted by, for example, this is Gaussian normal random variable, then x equals to mean and variance square. Okay, and then its PDF equals to P of x equals to Gaussian normal x, which has a mean and variance. This equals to 1 upon root of 2 pi sigma and exponential power of this. Now the next random and mixed probability PDF. before this is point probability. Means every point in a sample space has a probability. Let x be the discrete random variable. Then distribution of x is determined by the point probability pi. Then pi equals to, what is pi? Pi is the point random variable, equal to p of x equals to xi. Means what is xi? Xi is the ith measurement of x. What is the probability of 2 that it belongs to a roll and die experiment? So I is the ith measurement or ith outcome of x. Therefore it's called point probability. We are finding the each outcome probability that it belongs to the set of x. Okay, then xi is a sample of x. This x, suppose sample of x is included in the sample space. Then the probability mass function of x is a function Ex equal to 0 or 1. It will be either 0 or 1 and defined as p of x equal to this and this thing. If it is x equals to ith measurement of this sample space, then it equals to point probability, otherwise 0. Then what is mixed random variable? Mixed random variable is a hybrid random variable that 2 points meet at same point. Means variable x is one which can take values in a continuous set of x as well as over a discrete values of point 1, 2, 3, 4. Means suppose x is any value in a continuous set x which occur on discrete value point 1, 2, 3, 4, 5, 6. Such random variable has a PDF of the form. So p of x is a pc of x. This is a continuous time valued in the sample space of the x, plus this is point mass function or point probability, that sum of point probability and this function of x minus any point probability that is also belongs to the x. So this is point probability or point mass function is added to the continuous PDF of the x. So then the integral of p of x dx equals to this thing, integral of the p probability of the PDF of the continuous value to x plus this point mass equals to 1. The joint probability PDF of an event and the random variable is defined as, so joint means two things meet at same point, or the event A and this thing will occur at the same point, or it lie over the sample space. Suppose this is a sample space, means sample points, and this is any random variable x. This is sample points and this is any random value that belongs to the x set. So joint probability of the PDF is equals to, note that this is not a PDF, this is the probability. So in the object tracking theory, we represent capital P is a probability and the small p is a PDF. So this is not a PDF, this is a joint probability PDF. The joint probability of the PDF equals to limit tends to d epsilon tends to 0, and it's same thing, and is denoted without subscript. We can write this thing like p of a comma x. So we can denote the mixed or joint probability PDF like p of some variable comma some variable, and this is PDF, and this is probability of mnth. Expectation and moments of a scalar random variable. So what is the mean? Mean, or it can call the average value on the first moment of the sample space, or any average value of the sample space. For example, the die is rolled 3 times. Then what is the mean of x? That x is maybe we want to calculate the mean of the sum of the numbers that will calculated after all the times that we have turned the die. Means if we turn the die 3 times, then what is total number of the dots in each times of the rolling die. We sum up and divide by 3, and that will equals to whatever the value, it is a mean or average value. And the second central moment or variance is this thing. So this mean is the x is a random variable into PDF of the x, and integral of with respect to dx, and this is a symbol that we denote this thing. We denote a mean of x like x bar, and the variance like this equals to, we denote the variance like this, sigma x square, and we say that this is a standard deviation or variance. So it is equals to e of the mean square equals to integral of the mean square p of x equals to e of that. If we solve this thing, then it will occur like this: e of x square minus x mean square. A random variable x with mean x dash and variance sigma square will be denoted as this one. And the second moment, which is the mean square value, is equal to the square of the mean plus the variance, like this one: e of x square plus variance of x square equals to x bar square plus sigma square. So this is for zero mean random variable. The standard deviation is a root mean square value. Like this variance, the same thing. Here, if we solve this event of mean square, then it will occur like this one, and this will be equals to 0 because of crossing point, crossing the variable x. And what is covariance? The covariance between x and y is defined by this thing, expectation of the mean value and y minus e of y. Then you can prove it easily. Covariance of this thing is equal to e x and y, and e of x comma y. So expectation example, let S be the set of all sequence of 3 rolls of a die. Let x be the sum of the number of dots on 3 rolls. Then what is the e? Then we just to find the e of x, we just sum the number of dots on the three rows. Means 2 dot will occur, 2 dot is occurring 2 times, and 1 dot is occurring 1 times. Then 2 plus 2 plus 1 is 5. Divide by 3. Okay, so because we rolls 3 times, then we have to divide by 3 to calculate the mean of that event x.